Betelgeuse or Beetlejuice. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
The quick rise in Betelgeuse's brightness, which was discovered by physicist and science broadcaster Brian Cox, is a big deal in the field of astronomy, making scientists and space fans alike excited and curious. The James Webb Space Telescope, which is one of the most advanced observational tools ever made, recently noticed that the brightness of this well-known star increased by 250%. This caused a huge scientific response as scientists tried to figure out what was going on. Betelgeuse is a red supergiant star in the constellation Orion. Astronomers have been interested in it for a long time because it is very big, its brightness changes, and it might go supernova soon. On an astronomical timetable, James Webb's discovery of a sudden brightening adds a new level of interest to the study of this stellar giant. It may also give us new information about how huge stars die and come back to life. Before we start, click like and subscribe to get more exclusive stories. People have been fascinated by Betelgeuse for hundreds of years because it is one of the brightest and biggest stars in the sky. It is easy to spot because of its reddish color and noticeable place in the constellation Orion. Its changing brightness has been recorded for a long time. Since the star is getting close to the end of its life, it is likely to go supernova at some point in the future, though no one knows when exactly. In recent years, Betelgeuse has been acting in strange ways. For example, it dimmed down a lot in late 2019 and early 2020, which led to rumors that it might be about to blow up. That dimming, which was later found to be caused by a cloud of dust made from star material being thrown out into space, added a new part to Betelgeuse's story. However, the James Webb Space Telescope recently saw a sudden 250% rise in brightness. This is a different kind of puzzle, one that questions current ideas about what changes the brightness of red supergiants. With the James Webb Space Telescope, we can look at Betelgeuse with a level of detail that has never been seen before. It can pick up infrared bands that can show us parts of the star's behavior that we couldn't see before. When James Webb saw the rapid brightening, it stood out because of its size and speed, which are not typical of star variability. This kind of star, like Betelgeuse's, usually has slow changes in brightness because the star's outer layers pulse as it grows and shrinks over time. It is true that these pulsations can cause changes in light that can be seen, but a quick 250% rise is much more than what is normal. Since the brightness changed so quickly, it seems like something strange and possibly life-changing is going on inside or near Betelgeuse. One idea being talked about is that this brightness might have something to do with things going on inside the star, like changes in the rate at which stronger elements fuse together in its core. It is now a red supergiant and has burned through the hydrogen fuel in its core. It is now fusing helium and other stronger elements together. As a star gets closer to the end of its life, the fusion process gets more complicated. Layers of different elements are fused together around the core. A fast change in light could mean that these fusion processes inside the star are changing. It's possible that new layers are being ignited or that elements are being mixed quickly inside the star. In this case, we would get a unique look into the late stages of evolution of a huge star, which could teach us a lot about how stars like Betelgeuse get close to the point where they crash and explode as a supernova. Another interesting theory is that the brightness rise is caused by huge amounts of material being thrown off of Betelgeuse's upper layers. The star threw out a lot of gas and dust during its dimming event in 2019 and 2020, which made it temporarily harder to see. If the recent brightening is linked to another episode of material ejection, it could mean that Betelgeuse is going through a time of extreme instability marked by frequent explosions. These kinds of explosions might be caused by the star's internal processes interacting with outside forces, like magnetic fields, which can change the star's outer layers and cause big blasts. The matter that is thrown out during these events might then interact with the space around it in ways that make the star appear brighter, either by spreading the light from the star or by creating shock waves that send out more radiation. It is possible that magnetic fields play a big part in this. It is known that Betelgeuse has a complicated magnetic field, and new findings show that magnetic activity may be one of the reasons for some of its changes. The quick rise in brightness might be caused by a big change in the star's magnetic field pattern. This could be a sign of magnetohydrodynamic processes happening in the star's outer layers. Large magnetic loops or star spots may form during these processes. Star spots are areas of strong magnetic activity that are similar to sunspots, but on a much larger scale. If this kind of magnetic event really did happen, it would show how important magnetic fields are and how huge stars change over time, which is an area that is still not well understood compared to other things about stars. This quick brightness increase has effects on more than just our understanding of Betelgeuse. These effects reach into the field of astronomy and how stars die and come back to life. Even though stars like Betelgeuse aren't very common, when they go supernova, they add heavy elements to the space between the stars. Through studying the events that happen before a supernova, scientists can better guess when and how these explosions will happen. This helps us learn a lot about how galaxies move and how elements are spread out in the universe. James Webb saw a brightening that might be a sign of a supernova. If it is, it would be one of the most important cosmic events in recent memory, giving us a chance to see a star explode in amazing detail. But even if there isn't going to be a supernova soon, the information gained from this quick rise in brightness could still tell us a lot about how red supergiants behave in their last few days. Astronomers use Betelgeuse's sudden brightness increase to tell us that even stars we know a lot about can behave in ways we don't expect. It shows how important it is to keep an eye on changeable stars and be able to change how you look at them all the time when studying stars that might explode in the future. The James Webb Space Telescope's ability to notice such quick changes in light shows how useful it is to have state-of-the-art tools for looking at the world at different wavelengths. By collecting data in the infrared range, James Webb adds to what optical telescopes can see, helping scientists build a fuller picture of things that happen in stars. This event shows how important it is to have a variety of observational tools. Each telescope and device has its own special skills that, when put together, can help us figure out the most difficult puzzles of the universe. The quick rise in Betelgeuse's brightness may also make us rethink the theories that try to explain how huge stars behave. A lot of the models we use to guess how stars like Betelgeuse will change over time are based on studies of a small group of red supergiants and what we know about how stars work. A big event like this one might mean that there are things that affect the late stages of star development that aren't fully accounted for in the models that are used now. For instance, if magnetic fields or types of internal oscillations that were not known before play a bigger role in the unpredictability of red supergiants, this could mean that scientists have to change how they model these stars and try to guess how they will behave in the future. Astronomers may be able to improve their models to better show what it's like inside stars like Betelgeuse as they get close to the end of their lives as more data is received and studied. In addition, this event has implications for how we understand how cosmic dust is made and spread. A lot of the dust in the sky comes from big stars like Betelgeuse, which lose matter over the course of their lives, especially when they are red supergiants. The material that is thrown out includes carbon, oxygen, and silicon. Eventually, it turns into dust grains that are very important for making new stars and planets. Scientists can learn more about how dust is made by looking into the processes that cause material to be ejected and the conditions that make a star suddenly become brighter. The brightening could be connected to a new round of dust formation or the spreading of an existing cloud of dust. This gives us a chance to learn more about how dust is made and moved in the space between the stars. Another interesting thing about this event is that it gives us a chance to study how Betelgeuse interacts with its surroundings. If it's true that the sudden brightness ending is caused by the release of matter, the matter could interact with the medium around the star, creating shock waves or starting the formation of new structures in the gas and dust around it. Astronomers could study the physical conditions in the area around Betelgeuse by looking at the different things that could be seen, such as the release of light at different wavelengths. Knowing how a star's outflows change the area around it is important for a more complete understanding of how stars change over time and how massive stars affect their local surroundings. The quick brightness increase of Betelgeuse, seen by the James Webb Space Telescope, is not just a story about one star. It's also a look into the bigger rules that guide the life cycles of stars and the universe as a whole. With this sudden increase in brightness, scientists are having to look into new areas of research and different ideas to explain this huge change in brightness. The effects go far into astronomy, astrophysics, and stellar dynamics, giving us new ways to look at how stars change over time, how they make cosmic dust, and how these huge stars shape the universe itself. To fully understand how important this event is, it is necessary to learn more about the new science paths it could lead us down and the bigger effects it might have on our understanding of the universe as a whole. One interesting thing about Betelgeuse's rapid brightness gain is that it gives us a chance to study the late stages of nucleosynthesis in huge stars. Through nuclear fusion, elements are made inside of stars. This process is called nucleosynthesis. In red supergiants like Betelgeuse, this process includes the fusion of heavier elements in layers. This creates a wide range of elements that are then thrown into space during supernova blasts. But we don't fully understand how fast these fusion processes happen or how they affect the brightness of the star's upper layers. It's possible that the star is going through fast changes in its core or middle layers if the recent rise in light is linked to a faster phase of nucleosynthesis. This speeding up could be caused by the fusion of elements like oxygen, neon, or carbon, which burns in the early stages before a supernova. This kind of fast fusion could change not only how bright the star is, but also how its magnetic fields, pulse rates, and patterns of material release behave. Also, figuring out the exact processes behind such a fast rate of nucleosynthesis could have big effects on the way we study supernova sources in general. The more we know about the steps that lead up to a supernova, the better we can find other stars that might be about to explode. This has big effects on finding supernovae all over the universe and learning how they change the way galaxies evolve. There are a lot of heavy elements in the interstellar medium because of supernovae. The shock waves they send out also affect the birth of stars nearby. So, by figuring out what's going on with Betelgeuse's changes, we might learn things that apply to stars in general, which could help us predict when supernovae will happen in other galaxies. The warming of Betelgeuse opens up a new and important area of study, the physics of large-scale convective processes inside red supergiants. On the outside of these stars, there are bands of convection where hot gas rises to the top, cools, and then falls back down. Large pulsations that change the brightness of the star can be caused by this convection motion. Normal convection processes, on the other hand, probably can't explain a 250% rise in light. Instead, the event may point to more violent or unstable processes going on inside the star, which could involve huge amounts of material inside the star being flipped over. Figuring out if Betelgeuse's erratic behavior is normal or a sign that it is about to fall apart will help us make much better models of how star convection and magnetic fields interact. Red supergiants' convective movements are also linked to the way they throw stuff into space, which makes dust and improves the world around them. The link between the star's inner convection and its outer atmosphere could mean that the recent brightening event is linked to a strong mass release, which could be caused by more convective energy or changes in the star's magnetic field. Looking at this event can help us understand how the inside, outside, and area around a star interact with each other. These kinds of exchanges are important for both Betelgeuse and learning about how big stars die in general. When convective patterns change, they can cause big plumes or waves to form in the star's upper atmosphere. This can cause the star to lose more mass and change the shape of the medium between the stars. The rise in Betelgeuse's brightness also provides a unique chance to investigate the star's effect on nearby cosmic matter. Betelgeuse has a strong wind of gas and particles that has already made a bow shock as the star moves through the space between the stars. If the brightening is really happening at the same time as more material being thrown out, it could cause interactions that make the bow shock stronger. This could lead to new things that can be seen, like more emission at different wavelengths or the formation of new structures in the gas and dust around the star. These studies could give us a direct look at how a massive star changes its surroundings over time, making areas with higher densities that could finally give rise to new stars. This process connects the development of stars to the structure of the galaxy as a whole. It also shows how dying stars help fill the universe with the building blocks that will be used to make new stars in the future. The James Webb Space Telescope's ability to find these changes shows how flexible it is when looking at stars. Its ability to work in the infrared range is very important because it lets astronomers see through dust and gas that would block viewing with visible light. Because red supergiants like Betelgeuse throw off a lot of dust, James Webb's infrared tools can give a better picture of how the star is acting and what it has thrown off. The ability to do this is useful not only for studying Betelgeuse, but also for studying other stars at different stages of their development, such as protostars and the remains of supernovae. Because James Webb is sensitive to infrared light, it can pick up tiny rays from far away, dusty parts of space. This lets us see things that we couldn't see before. This could help us learn more about how stars are born, live, and die, which would eventually help us understand the whole cycle of life in the universe better in the field of astronomy. The thing that's happening with Betelgeuse is an exciting chance to push the limits of current ideas about stars. The quick rise in brightness goes against what scientists usually expect from such huge stars, which is why they are looking at the criteria they use to describe stellar variability again and maybe adding to them. To do this, we might have to change our ideas about what normal behavior for red supergiants is, or even find a new type of instability that other stars could also experience. This would have big effects because it would change not only how we study single stars, but also how we understand groups of stars and galaxies. By finding new patterns of variability, scientists could make the models they use to figure out the ages and stages of evolution of stars and star clusters or galaxies more accurate. This would make it easier to piece together the past of the universe. The sudden brightness of Betelgeuse has effects on study into other planets beyond our own. Because Betelgeuse is so big and unstable, it probably doesn't have any planets. However, learning about how stars like Betelgeuse change over time can help us learn about other stars that might have planets. If the same processes that make Betelgeuse brighter happen in other stars, they might affect whether or not worlds nearby are habitable. Increased stellar activity, like flares or magnetic storms, could, for example, change the climates or remove protected layers from the atmospheres of nearby worlds. So, learning more about Betelgeuse could indirectly help the study of other planets, especially those that circle changeable stars, by making models of how stars behave and how that affects the environments of planets better. This surprising event also serves as a lesson of how the world is dynamic and always changing. Astronomers can be shocked by quick and big changes in stars that they have watched for hundreds of years. People often think of Betelgeuse as a fixed point in the sky. But it's becoming clear that it's not that at all. Such shocks push the limits of what scientists think they know and make it clear how important it is to stay open to new things that test the way we think about astronomy. This means that we need to keep watching and being flexible, because even stars that look fixed can change quickly in ways that teach us new things about the universe. As Betelgeuse changes, scientists will be on the lookout for more strange behavior, such as more brightness or dimming, or other signs that changes are about to happen. If you look at Betelgeuse's past, this isn't the first time the star has changed in a strange way. Its light has changed over many hundreds of years, with records going back to ancient times. Chinese, Greek, and Roman observers all noticed that Betelgeuse's brightness changed over time. More recent views in our own time have also shown that it continues to change. A lot of people were interested in study during the dimming event from 2019 to 2020, when the star's light dropped to levels that had never been seen before. This led to questions about whether it was about to explode in a supernova. Even though the fading was later traced back to dust, the reasons for these changes still point to complicated processes going on inside or near the star. The current brightness might be linked to a larger pattern of repetitive changes in Betelgeuse's behavior. This could mean that the star is becoming less stable as it gets closer to the end of its life. The sudden brightening seen by the James Webb Space Telescope also makes us wonder if there is a link between Betelgeuse's changes and bigger cycles in the universe or environmental forces. Some experts think that the changes in massive stars like Betelgeuse might be affected by outside forces like cosmic rays, changes in the local magnetic field, or even gravity pulls from nearby celestial bodies. It's not likely that this is the main reason for the measured brightness increase, but it's possible that these kinds of things could change how the star behaves over long periods of time. If a link is found between Betelgeuse's actions and outside cosmic factors, it would help us learn more about how stars interact with their surroundings in ways other than through their own internal processes. Because it has a bigger effect, Betelgeuse's recent actions could also change how people explore and observe space in the future. As an example, Betelgeuse would become one of the most closely watched stars in history if it really was getting close to a supernova phase. Professional scientists and space agencies like NASA and ESA would both be interested in such an event. These agencies would likely use their resources to study the explosion across the entire electromagnetic spectrum. Future telescopes and space projects that want to find and study supernovae in other galaxies could be directly influenced by what we've learned from studying Betelgeuse. Astronomers might be able to find signs that lead up to a supernova in stars that are farther away and less clear if they know what to look for in close stars. This could lead to early warning systems for watching supernova events happen all over the universe. Furthermore, Betelgeuse's lighting event provides a chance to improve models of how stars change as they get older, especially big stars. Astrophysics relies on stellar evolution models to guess how stars with different masses and makeups will change over time, including how their size, brightness, and temperature will shift. The quick change in Betelgeuse's brightness goes against the predictions of models that say red supergiant's brightness changes slowly over time. Because of this, scientists might need to add new factors to these models, like more complex internal magnetic field dynamics or unexpected changes in how energy moves around in the star's outer layers. Improving the accuracy of these models not only helps us understand single stars, but it also changes how we study star groups and even whole galaxies, where the light from millions of stars makes them brighter as a whole. The changes that have been seen in Betelgeuse may also have a big effect on the study of ideas about how stars pulse. Stars pulse because their outer layers regularly get bigger and smaller, which is caused by processes inside the star like fusion and convection movements. Pulsations like this have been seen in many types of stars, such as red giants and supergiants. However, Betelgeuse's 250% increase in light over a short period of time does not match what is known about pulsations in stars. This strange event could mean that there are undiscovered pulsation modes or that pulsation is connected to other dynamic processes, like magnetic field interactions or mass ejections that happen from time to time. We could learn more about pulsating stars and improve how variable stars are categorized by looking into how these factors may work together to cause the observed change. This would help scientists better classify and understand the light curves of other stars. This warming also has effects on nuclear astronomy, which studies how elements are made inside stars. Betelgeuse is almost dead, and the fusion processes going on inside it have changed from just hydrogen burning to the fusion of stronger elements. This is the process that makes the chemicals that planets and life need. There is a clear link between how stars like Betelgeuse make elements and distribute them and the chemicals that make up the world. If the recent brightness is connected to changes in these fusion processes, it could give us new information about when and how elements are made in huge stars. In turn, this could help scientists figure out where the elements in the solar system came from, including the ones that make up Earth and other worlds. The rapid brightness increase in Betelgeuse has had an effect on science in areas other than astronomy and astrophysics, such as computer science and data analysis. Because so much data was received by James Webb and other telescopes while they watched Betelgeuse, it takes complex formulas and computer skills to handle and understand it. The noticed variation gives us a chance to try and improve machine learning models that are meant to find strange things in big sets of astronomical data. These models can help naturally find strange trends in the brightness data, see how they match up with past events, and guess how things will act in the future. Creating and improving these kinds of computer programs can be used for a lot more than just studying stars. They can be used in climate science, the stock market, medical imaging, and other areas that deal with big amounts of data. From a historical and cultural point of view, Betelgeuse has always been a big part of how people think about the night sky. People have been interested in the star for a long time because of its reddish color and unique location in the constellation Orion. It is often linked to tales, myths, and traditions. The quick rise in Betelgeuse's brightness is a warning of how the universe is always changing, something that has scared and amazed people for thousands of years. In the past, this kind of change in a star's light would have been seen as a sign. Today, it just interests scientists. People have come a long way in their ability to understand the sky, moving from mythology to science observation and thinking. The changing plot of Betelgeuse shows this. This event might get people interested in astronomy again, which could encourage future generations to look up at the stars with interest and a desire to learn. It's also interesting to think about how Betelgeuse's changes might affect the study of galactic history. The area of study called galactic archaeology looks at the chemical makeup and movements of stars and galaxies to figure out how they formed and how they changed over time. Researchers might learn more about how elements move around in the Milky Way by looking into what Betelgeuse does. Betelgeuse and other massive stars are very important to this distribution because they explode in supernovae, which send heavy elements all over the sky. The chemical makeup of the space between stars is directly affected by when and what kind of mass loss and supernova events happen. So, careful studies of stars changing a lot, like Betelgeuse, give us real-time information that can be used to improve models of how the galaxy evolved, how stars formed, and the enrichment process that affects the growth of solar systems and the possibility of life elsewhere. The sudden brightness gain might also affect the search for gravity waves. Waves in spacetime called gravitational waves are caused by the speeding up of very heavy things, like black holes or neutron stars colliding. So far, the most well-known places where gravitational waves have been found are during supernova blasts and catastrophic events like black hole collisions. If Betelgeuse went supernova, it would be a very rare chance to see gravitational waves coming from a known source in our galaxy. Even if the star doesn't blow right away, scientists might be able to figure out what gravitational wave signs to expect from different stages of a huge star's life by studying how unstable it is right now. This would add to the study that has already been done on gravitational waves and give us a fuller picture of the kinds of cosmic events that send out these hard-to-find signs. When looking at star populations, Betelgeuse's actions can help us understand how other red supergiants in the Milky Way and other galaxies change and die. Astronomers can get a general picture of red supergiant activity by comparing Betelgeuse's brightness change to changes seen in other stars of the same mass and age. This comparison can help us figure out if Betelgeuse's actions are normal or unusual, which affects how scientists understand what they see when they look at red supergiants and faraway galaxies. If similar events are found in other stars, it could mean that they are caused by the same thing in the late stages of stellar development. On the other hand, if Betelgeuse turns out to be an exception, it could mean that it is going through a rare or very dramatic phase of instability, which would make it a great example for testing ideas about how stars die. One of the most interesting science chances this event gives us is the chance to learn more about how shock waves move through the atmospheres of stars. The rapid rise in light might be caused by something falling off of Betelgeuse's surface. The falling thing might create shock waves when it hits the gas around it. These shock waves can heat the matter around them and send out radiation with different bands, like X-rays or radio waves. These can then be studied to find out what the released matter is made of and what the conditions are like in the star's outer layers. Such studies could give us details about the speed, makeup, and density of the material being thrown out, giving us a full picture of what is happening right before a huge star ends its life. This would make current models of mass loss and red supergiants and the science of how shock waves form around stars a lot better. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us how you think this discovery will impact space research? Thank you for watching, and see you next time.